Today we are going to learn about mastering load balancer algorithms. We will explore various algorithms used in load balancing, understand their applications, and develop skills to optimize server performance and resource distribution.
Welcome to our session on mastering load balancer algorithms. Load balancing refers to the process of distributing network or application traffic across multiple servers. It plays a crucial role in ensuring that no single server is overwhelmed with too much traffic, thereby optimizing server performance and reliability. Today, we'll delve into various load balancing algorithms, each designed to efficiently distribute traffic. Understanding these algorithms is fundamental for anyone involved in server management or network architecture. As we explore these strategies, you'll gain insights into how they can help in optimizing resource distribution and enhancing server performance. This knowledge will serve as the foundation for mastering more advanced topics in the field.
Round robin is one of the simplest and most commonly used load balancing algorithms. It works by distributing client requests across a group of servers in a sequential, circular order. Imagine a rotating wheel where each server gets its turn to handle a request. This straightforward approach makes round robin easy to implement and ideal for environments where all servers have equal processing capabilities. However, it may not perform well in situations with uneven server loads or varying request sizes. For example, if one server has fewer resources than others, it could become overwhelmed, leading to performance bottlenecks. Despite this limitation, round robin is widely used, especially in DNS servers, where simplicity and ease of implementation are valued. The least connections algorithm directs traffic to the server with the fewest active connections at the time of the request. This dynamic distribution makes it particularly beneficial in environments where servers have varying processing capacities or when connection loads are unpredictable. By evaluating the number of active connections, the algorithm ensures that no single server becomes a bottleneck, thus optimizing overall system performance. However, implementing this algorithm can be more complex than round robin, as it requires real-time monitoring of server connections. Furthermore, it is most effective in scenarios involving long-lasting connections, where the load can vary significantly over time. In such cases, least connections helps maintain balanced server workloads, leading to improved efficiency and reliability. IP hashing, or IP-based routing, is a load balancing technique that uses the client's IP address to determine which server will handle the request. By applying a hash function to the IP address, the algorithm consistently directs requests from the same client to the same server. This consistency is particularly beneficial for stateful sessions, where maintaining session data on a single server is crucial for user experience. However, IP hashing can face challenges if the client's IP address changes, as this may lead to session disruption. Despite this, IP hashing is commonly used in content delivery networks, CDNs, where it ensures that content is consistently delivered from the same server, enhancing performance and reliability for end users.
Weighted round robin is an advanced variant of the round robin algorithm, designed to address its limitations in handling servers with different capacities. By assigning a weight to each server, this algorithm distributes requests in proportion to the server's capacity. For instance, a server with twice the capacity of another will receive twice as many requests. This approach ensures that more powerful servers handle a larger share of the load, optimizing resource utilization across the network. However, configuring the weights correctly can be complex, requiring a careful analysis of server performance and load characteristics. In heterogeneous environments, where server capacities vary, weighted round robin offers a more balanced and efficient load distribution, enhancing overall system performance. Dynamic algorithms represent the next level in load balancing, adapting to real-time traffic patterns to ensure optimal server performance. Unlike static algorithms, which follow predefined rules, dynamic algorithms analyze current traffic loads and server availability to make informed distribution decisions. This adaptability allows them to respond to sudden changes in traffic conditions, such as spikes in demand or server failures, ensuring consistent performance and reliability. Implementing dynamic algorithms requires advanced monitoring and analytics capabilities to assess traffic patterns accurately. However, their ability to enhance scalability and performance makes them invaluable in environments with fluctuating traffic and high demand for reliability and efficiency. Selecting the right load balancing algorithm is crucial for achieving optimal performance and resource utilization. The choice depends on several factors, including the capabilities of the servers involved, the nature of the traffic patterns, and the specific requirements of the applications or sessions being managed. For instance, if servers have varying capacities, weighted round robin may be more suitable than simple round robin. Similarly, environments with unpredictable traffic might benefit from dynamic algorithms that adapt in real time. It's also important to balance the complexity of the algorithm with the benefits it provides, ensuring that the solution aligns with the organization's business objectives and technical capabilities. By carefully evaluating these criteria, businesses can select the most appropriate algorithm to meet their specific needs.
To illustrate the practical application of load balancing algorithms, let's consider a real-world example involving an e-commerce site experiencing rapid growth. Initially, the site used a round-robin algorithm to distribute its growing traffic across several servers. However, as traffic increased and server loads became uneven, the site experienced performance issues. By switching to a weighted round-robin algorithm, the site was able to allocate more requests to higher capacity servers, improving overall efficiency and user experience. In addition, implementing a dynamic algorithm allowed the site to adjust to changing traffic patterns in real time, ensuring consistent performance even during peak shopping periods. This case study highlights the importance of monitoring server performance and traffic patterns, adjusting load balancing strategies as needed, and continually optimizing performance to meet evolving business demands.